Yeah. Sorry for being the reason that you have to return from your networking break. It was a short break, but anyway, I hope that we can compensate it with what we want to tell you. We want to present you a quite easy integration of Tensorflow with SAP HANA, which was released with HANA 2.02. And we have a very easy to understand use case we want to present later as a live demo, which is the car brand recognition. And this is a little bit the agenda. We have a micro overview, then introduction, what is TensorFlow, how's the architecture. Who of you heard about TensorFlow? Just to raise your hand. So I think it's more concentrated on the right side and less on the left side, which is okay, but I will talk to you in our case. Yeah. We will not explain too much TensorFlow as such. We, unfortunately, because of the little time we have, we just explained it very briefly. For more details, we have included references to the TensorFlow functionalities. With me is my Chief Innovation Integration Architect, Jorge Plaza, who will explain you the technical integration details later onwards. So when to use TensorFlow, another short topic that you get a little bit hold of, what this is good for. And then, of course, the integration with HANA, how we can address a TensorFlow model directly from HANA. And if we can address it from HANA, then we can also address it from the ABAP application server. What that means is that we can bring this functionality quite close to our ERP environment, for example, which could be an interesting use case. And yeah, I think that's it for the moment, yeah. And then we have a short demo, as said, about the car brand recognition. Who is Sulzer? Who of you ever heard of Sulzer? Probably none, right? Which is not so surprising. This is because we are quite focused on the automotive industry. You can see this, probably you heard about these cities in relation with the recent news about some difficulties they are facing. So that's our main focus, and with that we have, fortunately, also some good input about how this industry sector, which is changing a lot, which has to change a lot in the next years, what they are looking for. And I think as a SAP integrator, it's always very interesting to know how these advanced analytics, machine learning aspects can be brought close to the ERP system like S/4HANA now. And if you have, who of you were at the TechEd this year? So some of you maybe have seen a couple of speeches in the Applied Intelligence track, which is related to intelligent enterprise and Leonardo integration. So this is all very close, and this year has been the year where bringing ERP logic and machine learning and artificial intelligence together into one solution stack. And I think that's a really very, very interesting and promising extension to what we were able to do so far. Yeah? So, yeah, what this is about today, you see two cars. Can you recognize the brand of each car? I think so, no? Maybe. So this is a German car, and this is a Spanish car. But if you forget about the logo of the car, you see that both cars look pretty similar, right? I think so, at least. Yeah, they share the same color, they have similar forms and light. However, we would like to have something that, for this simple use case, is able to detect what is the brand of the car that is included in the image, and which is something very simple for us as humans. This is something quite cumbersome and problematic initially for a machine. Yeah? And this is what this is about, and I would like to hand over to Jorge, who will explain you what is TensorFlow and how it can be integrated in SAP HANA.
Okay, thank you, Philip. So as Philip has told you, we are going to integrate TensorFlow with HANA, and how we are going to to classify and to distinguish which car brand belongs to these cars is with Tensorflow, which is an open source framework library, open source library for numerical computation developed by Google. And it's very popular because it's a very good option as an end-to-end library. And when we build a model in TensorFlow, it can be easily moved from prototyping stage to production. When to use TensorFlow or deep learning? Well, deep learning is a very empirical discipline, and it's often difficult to find hard and fast rules on when to use which kind of algorithms. And in fact, data scientists usually try a lot of models and techniques when they face a new data set or so on. But in general, if we have a large amount of training data, or we are facing an image, audio, or natural language problem, well, here deep learning and TensorFlow is a very good approach because it very often outperforms other deep learning algorithms. But if we are facing a problem that we can solve by making simple rules, or we have a small amount of the training data, here we can use classical machine learning algorithms, although they are comparable in their performance. TensorFlow is executed by the TensorFlow distributed execution engine, which is supporting a lot of front ends. And also Python is the most complete and easy to use API. It supports another languages like Java, JavaScript, Swift, Go, etc. It's also supporting some operating systems like Ubuntu or Windows, or can be isolable using Docker containers, like for example the SAP Leonardo Foundation, the Machine Learning Foundation does. And what kind of benefits can we get by integrating these tools? Well, TensorFlow is a very powerful tool by itself, but when we integrate this tool into HANA, we get some benefits like scoring images from an SAP system. SAP is also supporting TensorFlow in some versions in production environments, and some other benefits like stable column storage and so on. Well, for the main goal in this presentation, which is the integration between HANA and TensorFlow, we have to perform some steps. First on the TensorFlow server, and then in the HANA side. In the TensorFlow server, we have to train and export and then serve the model. And then in the HANA side, we have to install the application framework library, which includes the external machine learning library. Then we have to perform some configuration in the HANA side. And then when everything is up and running, we could be able to address some pictures, in this case, car brands pictures from the HANA server to TensorFlow. If we just want to pretend to build and to handwrite every feature of in this case, car images, like edge detection or shape detection, it will probably never work and will take forever, and because of the variance of real world. And here is where convolutional neural networks come into play, because when training a model, it acts like a black box and constructing features so abstract that they account for variance. And we are using here a convolutional neural network called Inception. Maybe some of you have heard about Inception. It's a convolutional neural network built by Google on 100,000 of images with 1,000 of classes. And well, but in our example, we are classifying brand cars, and Inception wasn't trained on car runs. So how are we doing this? We are using a technique called transfer learning, which means applying the learnings from a previous session to a new session of training. Because if we look at the images here, every image we input comes from here. The first layer in the network builds features, lower level features like edge detection, then shape detection, and they get increasingly more abstract up until the end. And in the last layer, we have highest level detectors for whole objects and in the end. So what we are doing when we are retraining a model with transfer learning, we are just retraining that last layer, and with this technique, the model is learning the features for car brands and is adding these abstractions to its repository of knowledge. This is the command we have used for retraining. It's a quite long command, but we have in the end we got a 94.5 of prediction accuracy, which I think is pretty good. We have also tried a lot, and we are integrating the TensorFlow with HANA with this library, TensorFlow library, which is a high-performance library which allows us not only to serve one model, but also several models, and some version of each one to a HANA server, and also for more than one HANA server, and we can score to the TensorFlow server. We can serve them by HTTP REST API or by the Google Remote Procedural Call, which is the adapter that HANA is using here. And the big advantage of this is that HANA here acts like a client. So all the workload is performing in the TensorFlow server, and we can score images from the SQL script in HANA. We can see here the TensorFlow side with a serving model. There's nothing to say about that because it's just a server running. Okay, in our case, we have like 600 of images, which is too small data set. But with the retraining technique, which is not the best option when we are building a model, because the best option is to have like several hundreds of images or even millions, and to build the whole model. But with the retraining technique, we can get a pretty acceptable prediction accuracy, like in this case. We can see the whole process took about 1 day and 2 hours, 3 hours, which is a lot. But the result is quite good. In the HANA side, we have to perform some steps like install the SAP HANA tools, EML, and add the script server to the tenant database, then create some users in case we need it, and authorize them for some EML procedures. Then we have to create a remote source and some other steps. I'm not focusing a lot in this slide because I'm going to show you in the next ones. Okay, here we are creating a remote source with the RGBC adapter to the EML TensorFlow server, registering the model, and applying the configuration in order to make the changes persist. And on the last command, we are verifying that this model, that the server is up and running. And in our case, we have to upload the images from the TensorFlow server, but in your case, you can have already your images in the HANA side. Here is where we perform the magic, the score. If you have ever worked with the PAL, with the predictive analysis library from HANA, this may seem similar to you, but it's some table inputs and outputs. And after we do the scoring, we could check the the results. It's more graphical view here. We can see that with 94.5 accuracy, 9 of 10 images have been predicted successfully. All but once, this one, with a very low probability of 52%, and also have confused. He's saying it's an Audi, but it's a SEAT. Anyway, this is such a low prediction that we can discard this prediction without even checking the image. This prediction accuracy then can be improved if we had more images, but they were downloaded from Google, so I didn't have more. And now we have prepared a demo for this presentation. We have here a Tensorflow survey running, and in our HANA side, I will check if the Tensorflow server is running. We can see here, I don't know if you are able to see it, but the model is healthy. It means it's up and running. I will check if all the images are in the database. They are all loaded. We have 5 images of if1. This is the blob. And I'm gonna check the future results, where you can see everything, nothing is loaded, because if all the results are with an iteration. And now here we are performing the scoring command to the Tensorflow server. It's take a while. And we check again the same command here with all the probabilities. And I will show you here. Let me do it. Not you. Can you see it here? No, give me a second. Can we duplicate the screen there? Let me. That's okay. So we have all the Audis here in the first row, and all the SEAT in the second row. And we have some good results in general, with 94, 99%. Some cars which have been successfully predicted.
I think have a look at the numbers and the pictures by yourself. You will find that some numbers are higher, and try to have a look at the picture, the corresponding picture for the higher numbers and the lower numbers. I think it's quite interesting to see under which conditions the model we had difficulties in saying precisely yes or no. This is actually the question we are answering. It's one or it's the other. It's not if it's not of one or the other. Yes, please. So that's Audi Demo 1, that's the first one. Audi 2 is 99, that's this one. It's by columns, sorry. Yeah.
Yeah, we have the very same name here is below the pictures.
Yeah. For example, a lower number is for the Audi number 3, which is likely to be related with it. It's not very sharp, and it doesn't have a high contrast. Yeah? So that might be the reasons here. Actually, we can't really tell you, because we don't know what really happened inside. Yeah? And I think also another very interesting result is this one. This is a very old Audi. You probably can recognize it. And I didn't want to offend anybody, just in case. Yeah? But that was number 4. Number 4 is still quite high. So even if the shape is quite different to all other shapes of the car itself, by one reason, the result is quite precise. Yeah? And then we have the Demo 1, the SEAT Demo 1, which also has a lower result, because we mostly took frontal images to train our model, right?
Yep.
So that's the reason here. And then we have this tuned SEAT here, yeah, where we do not have the symbol of SEAT, and here it says that SEAT is not a SEAT, actually it's an Audi, and that is wrong. Yeah? So if we have a look at these numbers, 80%.
It's quite low.
So
It's quite low, so
It's quite low, so probably we would need to fix the limit where we say this is where we are quite confident that the result is correct in 95 or 97%, yeah, which we would fulfill for many pictures. And with that, we have implemented a small car recognition example based on pictures, and that can be addressed from HANA, and with that we can address it also from ABAP, yeah? Maybe by using AMDPs or similar things. And that's it.
I think this is a pretty simple example, but also very clear and easy to understand. Right? So I think it's done. And you got any questions?
Are there any questions? I don't know if we still have time for questions, David? Yeah?
Yeah? So, okay.
Yes, please. I can't hear you.
It is not my question, but there was a question.
Yes.
Are you sure that it was using images and not the file names to train?
How long did the first training take? 20 hours?
This one took like 27 hours.
So we assume that if it would be, that would be images and not file names, because if it would take 17 hours to adjust its model on file names, then it would be, how should I say, not really a recommendable piece of software. Yeah, so. But we will do the test and get back with arbitrary file names. Yeah. I personally don't know.
Yeah, okay. How do you convince customers to use machine learning when you're not really sure how to test this?
By the results of the trained model.
Okay, so training and you get...
Yes.
Yeah, we have.
So it's, of course, you have seen that we used like 650 photos for that model to train.
Yeah,
So that's, it's not that much, but if you have to download 650 car pictures from anywhere, so it takes quite some stuff, yeah. Good. Any more questions? I would say thank you very much for your attention.
Thank you
I hope
very
you
much.
enjoyed it.